Hi there, folks. Today we're looking at absolute value inequalities. And an absolute value inequality, just like when we're solving absolute value equations, I had to kind of split this thing up into two different things. Well, here in absolute value inequality, I'm going to split up into two different things. So the absolute value equations, I got two different equations. And now with the absolute value inequalities, I'm going to get two different inequalities. But here's the thing, we already have a name for when we have two inequalities. We call them compound inequalities. Remember, we had two types. There was the and inequalities and there was the or inequalities, all right? And so really, if the absolute value inequality becomes two inequalities, it's got to be either this and type of inequality or the or type of inequality. They become compound inequalities, all right? And the approach to this is very similar to equations. So with the equation, remember, we had the absolute value equals something, and I would do it equal to that thing and then equal to the negative version of that thing. It's the same thing here, except when I do the negative version, I have to flip the inequality sign. So if you look at this, like right here, it says A, the absolute value of A is less than B. So I do A is less than B for the first one. And then I do A is greater than the opposite of B for the second one, okay? So I change the sign. When I change the sign, I flip that inequality sign, just like when I multiply or divide by a negative. Here, notice, look at this. It says absolute value of A is greater than B. So I start with A is greater than B. And then when I do the opposite version, the negative version, I flip the inequality sign, okay? And so that's really it, other than the word that goes in between. Notice one of these has the word and one has the word or, and the easiest way to do that is just a little bit of memorization. When the absolute value is less than, it's an and. And notice I just said the word less than a little funny, okay? It's still an easy way to remember it. The absolute value is greater than is an or, okay? So less than is an and, greater is an or, all right? And that's all we have to do to remember to whether to put an and or an or in between there, okay? For example, if I look at something like this guy, so here I've got the absolute value is greater than 10. So when we did equations, we would do the x plus 4 equals the 10. And then I would do the x plus 4 equals the opposite of that thing, which is a negative 10. But now here, instead of equals, I have an inequality. I just copy it down. It's a greater than symbol. And when I do the negative version, I flip it and make it a less than symbol. Okay. Now the only other thing I need to decide is what symbol goes or what word goes in between. Since the absolute value is greater than, so greater is an or. So I put an or in between. And now to solve a compound inequality, I just solve the two inequalities separately. So here I subtract the 4 from each side. Over here, I subtract the 4 from each side. My or tags along for the right, and that's it. This is my answer. The only other thing that I might do here is I would draw a quick sketch of the graph just to make sure my or inequality looks right. I would say, oh, well, let's see, greater than a 6, open dot and shaded this way, less than a negative 14, open dot and shaded that way. Okay? And that's what or inequalities are supposed to look like. We have two separate pieces, one or the other. Okay? If I look at the next one, same kind of thing. If this was an equation, I would do the positive 6 and I would also do the negative 6. But since it's an inequality, I just copy the inequality sign down. But when I do the negative version, I have to flip the thing. Okay? Now I look at it and say absolute value is less than. So less than is an and. So I just put the word and in between. And now I solve each of these separately. So here I add the 2 to each side. And then divide by the 2. Over here, same kind of thing. I'm going to add the 2 to each side. And then divide by the 2. That and tags along to the right, but now wait a minute. This is not how we usually write and inequalities. Remember, and inequalities we usually write as one string, so remember it's always least to greatest. So the c is negative 2, so the c is between a negative 2 and a positive 4, and then I can fill my less than symbols in between there. Okay, that's what an and inequality typically looks like. If you write it with the word and in between, that's going to be okay. That's technically correct, but this is the best way to write our answer. Okay, and when you go to graph it, it's easy to see that the -4 is, or the C is between the -2 and the +4. In fact, when you look at those original inequalities, it says less than or equal to the 4 and greater than or equal to the 2. So bigger than the 2 but less than the 4 is in between the -2 and the 4. Okay? If I look at the next one, same kind of thing. I say, hey, I've got the t plus 2, so I use the 5, but then I also use a -5, just like I do with the equations. But instead here, I copy this inequality sign. When I do the negative version, I flip it. Absolute value is greater. Greater is an or. And now I solve each of these. Subtract that 2 from each side. T is greater than 3. Over here, I subtract the 2 from each side. T is less than a -7. Then we slap our or symbol down. That's it. Okay, let's draw a quick sketch of the graph, because that feels good, right? -7, +3. Let's see, it says we're greater than the 3. That's like this. Less than the 7's like this. Notice my use of those open dots. And that's what an or inequality is supposed to look like. Remember, we have the two different pieces, okay? The next one here, again, we got to isolate the absolute value first because we're working backwards through order of operations. Absolute value is inclusion symbols, so we undo those last. So I need to undo that times 2 first. To undo multiplying by 2, I divide by 2. Now I'm left with just the absolute value. To get rid of the absolute value, that's when I start breaking this thing up. I get rid of the absolute value by doing the x plus 5 with the 1 and the x plus 5 with the -1. And now I copy this guy down, but I flip the inequality symbol when I do the negative. And now I solve each of them. Oh, wait, sorry. Let's put the and or the or in there first. Absolute value is less than, so it's an and. Remember, less than is an and. Now let's solve each. Here I subtract the 5 from each side. So I've got x is less than or equal to a -4. Here I subtract the 5 from each side. I get x is greater than or equal to a -6. The and tags along, but that's not how I would normally write an and. Normally I write the -6 first, least to greatest. And then look at the symbol here, see? The alligator's pointing towards the x. And I'll combine it with this piece, the x and the alligator pointing towards the -4. Okay? And then, of course, the graph of this thing. I'm really squeezing this in here. We've got a closed dot at each, and I'm shading everything in between. That's how and inequalities work. Okay? The last one here. It says a company producing boxes of crackers have a 5-gram margin of error. If each bag should be 213 grams, what are the allowable number of grams for each bag? And here's the thing. It's a bit of a stretch to come up with a word problem for an absolute value inequality, all right? Most of you could probably do this, could go to the answer without doing the work of the absolute value. And I wouldn't expect you to do all the work with the absolute value, all right? The point here is that any word problem that would involve absolute value, we would typically solve another way. So let's think about the answer here first, okay? Let's think about it in terms of an inequality. It says each bag should be 113 grams, but there's a 5-gram margin of error, which means I can be off by 5 grams in either direction, all right? So if I'm supposed to have 213 grams, if I'm off in the low direction, like if I'm 5 grams too light, all right, it means that I would end up with 208 grams, all right? But if I was 5 grams too heavy, 5 grams in the other direction, I'd be at 218 grams. In other words, my value for x has to be greater than or equal to the 208, but less than or equal to the 218. This is the answer to this question, all right? If it asks us to write an absolute value inequality, and again, I just want to show you where the practical application of this comes from, is we'd be looking at this saying, hey, you know what? The 213 minus x, the absolute value of that has to be less than or equal to a 5. Okay? In other words, to find the margin of error, I take the 213 minus the x, or the x minus the 213. Either one would be fine, and maybe it's probably better to do it the other way. But to find the margin of error, I would just say, hey, x minus what it's supposed to be, that difference has to be less than or equal to 5, or the absolute value of that difference has to be less than or equal to 5. And so as we kind of solve this thing, let me just set it up real quickly to show you we get the same answer that we have written over there. Oh, sorry, greater than or equal to. See, I'm trying to rush. And see, it's less than, so it's an and then I solve each. And notice, this seems strange. You're probably looking at me going, Mr. Jansen, why would I do any of that when the problem basically says to add or subtract 5 from the thing? Yes, you would absolutely not do the absolute value for this. You would go right to the answer. But this is where the application of this thing would come into play. Okay? So here's the 218. Over here, when I add that guy, here's the 208. Oh, that is probably the worst less than or equal to symbol I've ever drawn. And now, of course, I would rewrite it as one string. And there it is. I got the same thing that we got just by kind of thinking about it, okay? But hopefully you can see that even though this one was really easy to solve just by going right to the answer, where the application of the absolute value inequalities come into play. All right. But again, absolute value inequalities, we split them into two inequalities. When you do the negative version, you have to flip the inequality sign. And then remember, you have to use that and or qualifier with the inequality. If the absolute value is less than, it's an and. If the absolute value is greater than, it's an or. Okay. Less than is and, greater is or. All right. But again, you split it up into two inequalities and solve each. All right.